you would like to get a quick overview, or if you're working with a student, if you're looking for like a single, like one-stop shopping where you like, get a really good overview of the related work, I think this is a good paper to start with. And, but we try to go a little bit further in the sense that we try to kind of work out some sort of a roadmap, and I'll talk about this a little bit more in a couple of minutes, where we try to look at, how have other fields kind of progressed and what can we assume for the future and what needs to be done here. So the key question we're going to discuss also in the panel, and we're going to invite all of you to join the discussion. So I think this is reasonably small. We can, just pretend we're all on the same panel together. The question is, what's the future of person fabrication? Is what we see right now, is that the end of it? Is this like person fabrication like a maker thing? Or is the maker phase some sort of an in-between thing? Is that like some sort of catalytic element and it's really going to go somewhere else into some bigger and better things where it's going to be 100 or 1,000 or 10,000 times bigger? Will it become a mass phenomenon? That's the key question we want to discuss in the panel today.
All right, and for that purpose, we went out and we compared it to similar trends we have seen in the past for personal computing. And from those similarities, we actually tried to extract a kind of roadmap for the future of fabrication. So as here you can just see 2 pages from the paper, basically talking about this history overview, looking at music editing, video editing, how did these things develop. And beside that, Patrick already mentioned it, we also survey the related work, and for each of these papers, we also include figures. So it's really easy for somebody who's new in the field to actually skim through and get an idea of what this is all about. So you already mentioned it, there's a free download during Chi, and also if you email our editor, James Finlay, you can get a free print copy. All you do is you say, I went to the session, can you please send me a copy? And I'm going to put up those things at the end when we have the panel, so you can actually kind of type this up. So we felt it's pretty hard to squeeze this 140-page paper into a session. So what we are actually going to do is we have a short summary about this paper, but then we thought it's also more interesting for you to hear about different perspectives. So we actually invited a couple of friends, so Mark Ross from UC Boulder, Bjoern Hartmann from UC Berkeley, Jen Mankoff from CMU, and Karthik Ramani from Purdue, who are going to sit with us here on the panel. So the way we are going to do the session is, we first have short introductions, so everybody's going to tell 2 minutes about their background, just that you have an idea who are the people on the panel. Then I'm going to tell you a bit about how personal fabrication actually developed at Chi over the last 5 years. Then Patrick gives a 20-minute overview of the journal paper, and we conclude with the panel discussion, and we invite you all to contribute your viewpoints and engage with us. All right, so let's start with the 2-minute introductions. Maybe Björn first.
All right, so here's my main challenge for personal fabrication. How do we get away from designing trinkets to designing useful products? And so most products are not just shape, but they have embedded electronics and functionality. And even for the ones that are largely shaped, so this is a custom snowboard I recently fabricated, you have some important engineering and material requirements to make sure that product is actually safe enough to use. So I think both about what kind of objects we fabricate and how we do so. For example, my group's exploring the middle ground between manual work and fully automated fabrication. Like our set of augmented power tools here, where you can load projects into the tools, which then guide you through the different manual operations, here aligning and drilling to a certain depth. And that allows you to work at larger scale and with different materials than you could in today's kind of additive manufacturing. Many physical products are also essentially shells for electronics. However, designing that intersection between shape and all of these components is cumbersome, detailed work. So here's a prototyping tool we recently showed that lets users sculpt and annotate where, for example, electronic components such as UI components should be located. You then 3D scan the annotated object, and based on that 3D scan of the geometry and the annotations, we can then automatically do geometry processing to basically shell the object and generate lots of bosses and mounting points, so afterwards you can just 3D print it and snap in components from a supported library. So here we're showing .NET Gadgeteer. We've also looked at other ways to support interaction prototyping, such as 3D printing objects in such a way that when you add a single sensor after the fact, in this case a camera, your object that was previously just inert plastic can turn into an interactive testable artifact. Now, finally, we're working on the question of how to help users design the internal electronics and not just pick off-the-shelf components and wire them together. So, interesting statistic, right now in the US, we're educating about an order of magnitude more coders than electrical engineers. So, to me, that brings up a question or a vision. Could you just start by writing the code of what your device should do and then automatically infer the schematic and the connectivity diagram and the requirements for the electronics so that you can then either automatically fabricate it or even give people, if they want to manually build it, step-by-step instructions for doing so. So to sum up, to me, many of the interesting fabrication challenges are not just shape, but they're at this intersection of multiple different domains. Thank you.
Hi, everybody. How are you making it so far? So yeah, I'm Mark Gross from the Atlas Institute at the University of Colorado Boulder. And I feel a little honored and a little bit of an imposter on this panel because I feel these people are doing amazing work and I'm honored to be part of this. I was going to just show you two videos, but Patrick explicitly asked for one. So a few years ago, Michael Mueller did this work on a hub and strut construction kit. So you snap these pieces together, it's a modeling kit, and there are sensors in the hubs and in the struts that send data back to a host computer to construct the geometry and the topology of the model. So here we're building a dinosaur, and you can see it being modeled there in the bottom right, and then eventually we'll skin it with a dinosaur. So we built a few different applications. The idea was to build a platform for this kind of modeling. And I was asked to stick to 2 minutes, so I'll do that. Some of you saw work that we originally titled Sketch It, Make It, and we now have a little company to fabricate this. So this is sketching for digital fabrication, for laser cutting, and eventually for 3D printing. No tool palettes, no keyboards, just the kinds of gestures that you might make if you're drawing on paper and pencil, and then you want to pass it automatically to some fabrication device. So if any of you are investing, we're looking for seed funding right now. And then last but certainly not least, current work. So this is work by Hyunju Oh, who's sitting there in the back. So this is paper mechatronics. Oh, I want to start with, I should have started there, huh? So the idea is to build these kinds of paper automata, toys. The target audience is novice designers. Engineering can be fun, but we often teach it in a way that's not fun, and we eliminate a whole crowd of people who could be actively engaged in engineering. So there's a set of mechanisms that you can choose from, and once you choose a mechanism or a kind of movement, you can animate it, bring it into a modeler, change the parameters, and when you're done with that, you can print it out onto a laser cutter and assemble it. So we have tutorials for all those things, and very successfully had middle school girls building mechanisms in paper mechatronics. So I want to conclude just with the idea that, and we heard a little bit of it from Bjoern, design is not just geometry. The history of computer-aided design has been geometry first, and we should be past that stage and think about functionality. Design is the decision-making process, and what's important is how the things behave as well as what they look like and what they're shaped like. And fabrication is more than the interface. So it's not just how you get the data in, but what the tool path is and the tool chain is from idea or from thought to thing, and how we get all of the designs through the whole path that gets us to the end. Sorry, I'm rambling, so I'll stop.
Okay, so I'm Jen Mankoff from Carnegie Mellon, and I was told to show videos, so I made a video. So hopefully it'll work out. And what I would like to talk about is our lab's work exploring things that have to do with the challenges and needs that end users face when making designs. And so the first one I want to talk about is measurement. And this is work, by the way, done jointly with a bunch of people. I'll show some references at the end. So we asked people to measure things on Mechanical Turk, and they were really bad at it. And so we started thinking about what it means to design models that are built for uncertain measurements. So this is an example of a buffer that is flexible so that you don't have to have the diameter right, or a piece that you can maybe take apart and extend by reprinting only part of it. This is a thing that you can screw together. So that work was just beginning to explore this question of measurement as one example of a challenge. Another challenge that I think is important is using attractive materials, things other than plastic. And so here is a project that we did looking at how we could make it easier to design objects for knitting machines. So this is showing the kind of design that knitting machines normally take. And these patterns are made of a combination of tubes and flat areas. And using the compiler that we developed, we can make curves, we can make shirts, we can make gloves, a wide variety of different things. That sort of explores how we can translate the machine's language into something easier for a person. This I have a very brief video for. It was already shown at CHI this year, but looking at printing on cloth, also in that domain. And then the last, or the next thing I want to talk about is attachment. So if you're building things to the real world, they want to feel good, you need to measure the real world correctly, but you also need to build them so that they can interact properly with the real world. And so here you see a tool that makes it easier to build out attachments to existing objects in such a way that they can securely attach. And by the way, believe it or not, I'm going fast. This is 2 minutes and 30-second long video, so I'm over my allotted time. The last thing I want to show is our work exploring models that encode more than just geometry. So these models encode information about how to integrate with other objects, or how to tell when assertions about how they should operate are violated. And then when those are resolved, you can print something that is functional. Okay, thank you.
Thanks for inviting me to be a part of this panel, Patrick and Stephanie. So I'm Karthik Ramani from Purdue University. I'm actually a mechanical engineer, so I have maybe different viewpoints on certain things. But I wanted to show you a bunch of things we have published in the last few years. And this was just using a phone to create objects, because partly we think making design easier is so critical to make real things and more complex things that we want to make. So just using your embodied interactions, moving, sweeping, changing, and so on and so forth. And also coming up tomorrow, although this is not in a fab session, we demonstrated how complex objects can be created in team settings very quickly across people to explore large design spaces. So if you have time, come to this talk tomorrow. It's in the last session at 2:30. So exchanging parts and so on and so forth. So making design easier. So also making more complex things accessible. Changes the way we think about making. And another interesting work that we did and presented at CHI is this thing called Cardboardizer. Will is here in the audience. And here what we did was we brought in a lot of the complex knowledge that is normally not accessible. And as you can see, like Mark was pointing out, much of design in the past is called computer-aided design, and computers came first, but now we are putting people first. So CAD and detail algorithms and everything have to be rethought if you have to put humans in the center and make it more accessible. So a lot of the constraints for fab are actually built into the software. So for that vertical, for making folded constructs, whether it's wood, sheet metal, and so on, it can be done fairly easily by a much greater variety of audience. And this was a paper that was presented just 2 days ago, mixed fab, and we designed a special wire bending machine. And then conceptually, this could be very large structures too, because if you were able to bend metal and so on and so forth, you can make larger structures as well. And finally, I'm kind of winding down here. RevoMaker was an earlier work that we did, mainly to show how functional objects can be produced off a single printer, including motion and also electronics. And last but not least, one of the pieces of work that our lab actually ended up spinning out as a company, and Zero UI actually won the Best of Consumer Electronics show last year, is to make robotics easy, simple, and accessible by children, but uses a lot of intermediate components which are made out of cardboard in this case, sort of very analogical to the other piece that was presented, I think today, using cardboard to prototype machine tools and so on and so forth. So anyway, that's pretty much what we have. And finishing up, I just wanted to show this was created by our student without using a computer, without using any CAD. He spent a whole summer building an Iron Man suit for himself. So.
All right, so I'm Stefanie Mueller. I'm a new assistant professor at MIT CSA, and before that I was a PhD student with Patrick, and this is why we are here today together. So my research is in two main areas. The first one is new interaction paradigms for personal fabrication, and then the other area is faster prototyping and design iteration. And I've published quite a bit on this topic. I just want to show you two examples of this work. So the first one is a system called Constructible, and the key idea here is that instead of using a digital editor, users actually work directly on the physical workpiece. So just showing you how to make this object here with the system. So users just take a laser pointer and they directly draw onto the piece of wood here. And as the user lets go, the system directly comes in and cuts this piece out of the wood. And so the user can basically iteratively design, and after every editing step immediately gets physical feedback, can take out the workpiece, can do some testing, and come back and keep making changes. So the other type of work I did was a lot on how to actually make prototyping faster. So here you can see on the right side the output of a system that we built called WirePrint, which, as you can see, is 8 times faster here than if you just do the normal 3D printing. And the idea here is that while you're actually designing objects, you often just want to test certain aspects of that object. For instance, here the shape. And to test the shape, you actually don't need the solid walls. You can save a lot of material and time there. So the reason why this technique is so fast is that we do not print layer-wise, but actually also into Z direction. So we see the printed here also moving upwards as the printer is extruding the material. And so to make this easy for a user, we built a piece of software. You just load your 3D model, you click one button, it converts it to a wire frame. And as you export, you just send it to your 3D printer. And the printer is basically printing it here just in 14 minutes. So imagine how many more iterations you can actually do in a single day here. So as I said, I just started at MIT, and I'm setting up a new team, and so we're also looking for new collaborators. So if you're interested in this type of work, please speak to me after the session.
All right. So my name is Patrick Baudisch, and as soon as this has loaded, I'm using PowerPoint 2008. All right. All right. All right, so, and I'm a professor at Hasselplatten Institute. So as Stefanie just said, we've published some, I don't know, like 10 papers together on things like constructible and laser origami, how to bend things with a laser cutter. And here are a couple of other things that we've been working on. So with my student Alex Ion, we're looking at metamaterial mechanisms, which is the idea of designing the inside of objects. You might have seen some. She actually has some of in the demos upstairs. The idea is to subdivide an object into cell structures and kind of design that in a way that it performs a mechanical function. Kind of thinking about how wasteful it is that 3D printers today just filling objects with kind of predictable structures that don't do much. we can actually use those structures to give them a decent amount of mechanical behavior, all of which is performed in a single object. So the talk that Alex just gave, I think yesterday, is how to extend that in a digital direction. So we're kind of reinventing the 19th century here to a certain extent, and thinking about, you know, if you have a 3D printer, what if the cells could actually perform some mechanical behavior? In this case, we out spring load them. They can kind of pass on mechanical impulses in a digital way. Every single cell refreshes a signal. That's obviously huge issues in a variety of ways, but we're just trying to ask the question, what could we do on the inside of objects in terms of giving objects behavior rather than just caring about shape? And so we hope that this will stimulate some interesting discussion. This is unpublished yet. I'm showing off with the work of Karthik Ramani, who is actually sitting in the third row here right now. He's currently looking at how to reuse mechanisms. So if you're trying to create a new machine, it's very difficult to do. How can we allow people to remix machines that you find on the internet by ripping components out of one? And what is the right element of sharing, which is a very interesting question. In programming, there's this notion of a class and an object, which is kind of the best entity for reuse. And the question is, what is the corresponding entity in mechanical engineering? So this beautiful object Thijs created out of, this centrifuge is vials, but it's actually made of a siren and a record player and something else. My student Rob we're working on large-scale fabrication. So we did a project together with our interns Harshit and Udayan called Prototyper that allows people, kind of like a 3D doodler but larger, to sketch large physical structures. And then you probably saw this upstairs. We have a talk and a demo here called Truss Fab that allows people to create large sturdy structures that you can actually, you know, add a load to. So it overcomes not only the issue of the limited print volume of 3D printers, but also essentially helps people to deal with the 10 to 100,000 times larger forces involved. So this is the structure that you probably saw upstairs, and this was a tremendous load of fun to set this up. At some point, the SVs who helped us were surprised that we had never set this up before, so we had no idea if this would work. I'm glad it did. All right, I'll be back here in a couple of minutes, so thank you.
There we go. All right, so I thought I'd just give a quick 5-minute overview of where personal fabrication actually came from in HCI, when did it start, and how did it get started. And I made this graph here actually a couple of years ago, but I think it's really interesting if you look at it. So this shows the number of papers published in personal fabrication in the HCI and graphics community. And I think there are two interesting things to see here. A, it's still a very young field, right? So you can see the first session was actually around 2012. And the second thing you can definitely see here is there's a tremendous growth in this field. So I still remember actually when we had the very first Fab session at WIS 2012, and I'm super happy to see some of those people here on the panel today. So Bjoern was there, Scott Hudson was there, and then Patrick and I were there, and a couple of other people, Amit Zoran, and so on. So at that time, we were only a couple of people, right? Like 4 or 5 people doing personal fabrication research. And that was also still true at Kai 1 year later. So Kai then also had its first personal fabrication session. But if you look at the program today, it's actually pretty overwhelming, right? So we have at least 5, 6 sessions on personal fabrication now. There are plenty of demos and posters in addition, right? So the community is really rapidly growing. And over the last years, we also organized these fabrication lunches every year. And I still remember we had one table normally with 5 to 10 people. And this year we had more than 40 people. And I actually had to close the registration at some point because the restaurant couldn't give us more tables. So that's very exciting. So I'm not sure how many of you went to the Ben Schneiderman keynote on Tuesday, but I really liked his overview of how a field gets born and grows over time and what it really takes. And I think he explained it for HCI, but I think the same is true for any subfield such as personal fabrication. So he basically said every field first starts with some articles and some presentations, what we have here at Kai. But then actually the next step going forward from this is workshops, right, where people can meet, build up a community, and actually start the first collaborations. And I think we did a really good job. So we had the Kai 2013 workshop on Fab, actually by Bjoern and Mark. And then Patrick and I organized a workshop last year with Laura Devendorf, Madeleine Gannon, and Yuichi Okai, and Stalin Koros. And after the technical HCI community got started, there's also more work now from usability and user perspective. So there are more and more workshops coming around the corner. So what's the next step after having workshops in the field? So Ben Schneiderman said it's actually a conference. And it's very exciting for me to see that this year we're actually having the first ACM conference on computational fabrication. So a lot of people here in the room actually submitted papers to the technical paper track, and people from SIGCHI also submitted. So that's really cool. So in the last 5 years, I think we have come really a long way, and I just showed a few things, but there's actually a ton of more stuff happening. So we had a Crossroads special issue on fabrication. A couple of years ago, I was super excited that fabrication is now a keyword you can click in PCS, right? So we now have a community that actually has reviewers reviewing fabrication papers. That was not the case 2012. We have a first summer school this year with 30 PhD students in fabrication. Yeah, so 30 PhD students doing their PhD over 5 years publishing papers. So I can see the community growing even more on that front. We now also have an archive for related work in fabrication. I will put the shout key up again on the last slide. So this is a website where you can basically browse through all the papers. You can see the videos immediately. You can go to the website of the authors and so on. And I think the biggest sign that the topic really reached the community now is actually that the opening keynote was also on 3D printing, right? So we're definitely there yet. So we actually thought it's now a good time to zoom out and talk about where the field is really going, right? So we are 5 years in. And it's really funny for me that Ben Schneiderman also said, okay, so after having articles, the next one's actually a review article. And this is exactly what we did, right? So we have the survey article, but we go one step further by actually laying out a roadmap for research questions and where the field should be going. And Patrick is going to give a around 20 minutes overview of the journal paper, and then we start the panel.
So a smart person once said, that part of the paper. But nonetheless, I think this, let me actually use this opportunity here to talk about the unproven side of the article, which is the future. So, as I said, the survey is a good basis for like an overview of 200, 250 articles. But let me actually look at this idea of a roadmap, because ultimately, as researchers, our job is to kind of live in the future and find out, you know, where we should be going and kind of be there and do the right things before other people tell us to. All right, so let's look at what's going on. There's all these fantastic new machines. You know, latest Ultimakers are like 3 years old. Hewlett-Packard just entered the market like a year and a half ago. Fantastic new continuous liquid interface production by Carbon 3D. And then we just saw all great fresh stuff. You know, it's only 6 years that all this stuff happened. So obviously, all fab is brand new, right? Is it? And the answer is not really. And I know many of you know this, the first 3D printer actually was invented in 1987. And if you go back to laser cutting, that's even 20 years older. And so the weird thing about fab right now is that we're in a phase that I would describe as a tech enthusiast phase, which is some sort of an interesting phase in the technical evolution. So this phase actually started in 2009 with MakerBot, and this actually was not caused by a great new patent or a great invention. It was marked by the end of a great invention. So in 2009, the first patent on this space expired, which was the patent on fused deposition modeling, which is essentially this idea of squeezing hot plastic through a nozzle. So once this kind of expired, then like the maker scene kind of started to exist in that space. There were makers and craftspeople before that, but the specific flavor started to exist then. But if you go back, as I just showed, there was already like a history of like 40 years before that. And so I think what's interesting about, so when we talk about person fabrication, it's novel, but it's not the fabrication that's novel, it's the person that's novel, right? So fabrication has been used by industry and prototyping and all these things, but we have a transition to personal the same way as in the word personal computing, right? Personal computing was not, the computing was not new, it's what's the personal new. It's the idea that it's used for individual use and so on. And this is actually a good point for the Chi community to get in, because that's kind of the types of discretionary use and all those things that the HCI community has been very good at examining and contributing to over the past years. So for me, the key question is, where is it going to go? I think there's different futures that we may have ahead of ourselves. One possible future is that that's it, Well, and if we meet again in 30 years, we'll still be hanging out with people in fab labs, and there's going to be like one in every major city and, stuff like that, and that's cool. But there may also be a future in which this whole field has exploded by a factor of 1,000 or something like this, and we're going to deal with a much larger audience, and 3D printing and laser cutting, whatever machinery comes up, could be part of like the mass consciousness the same way that mobile devices are. So today I'm not even saying I'm going to use my mobile phone, I'm saying I'm going on Facebook, and the device is already just like part of the mass consciousness. So for me as a researcher, I think that's the future I really want, right? Because if we could make this happen, then everything we do today would have tremendous impact. So if, as long as we're only with the maker community, that's a good practice ground, but it's hopefully not where it's going to end. So we could have tremendous impact. This is the type of stuff that actually is research is about. So in absence of a better term, I will call these consumers, and we just talked at this lunch this morning, may not be the best term. Mark suggests that could just be called citizens. Then I pointed out that I'm not a citizen here. So just non-makers. Someone actually proposed the term casual makers, but I'm not sure that's the best term because these are really not makers, and we're going to talk about this in a second. They're very different. So interesting question is, what will these people then do? Let's imagine there was this future where like 1,000 times more people would use fabrication. What would they do? And the answer, well, it's easy. Let's just look at what the makers are doing and let's extrapolate from here. So let's go on Thingiverse. That's the front page, loaded this morning, and aha. Fabrication is all about making Master Yoda. And I think that's a little bit of the issue with this whole maker movement, right? The maker movement, and I'm proud to say, like, no offense, right? I consider myself a maker myself. I'm not trying to offend anyone, but people like us, we're like, okay, I've got this 3D printer, let's find something out. We just had 1,500 bottles, let's make a pavilion. But it turns out the way this is approached is like technical challenge is rewarding, and the outcome is kind of not that important, right? I'm not sure how, anyways, I think we all have examples for these things. And that's quite different from what consumers do. Consumers is like, I have a problem and need this solved, outcome matters. If there's multiple ways of getting there, I'd rather choose the one that has the least resistance. And so in some odd way, even though in technical evolution these two parties are really butted together, like next to each other, and the makers are kind of catalytic elements that make it happen by bringing price down and creating technology and all this stuff, at the end of the day, the makers are not part of the final product. They're really just catalytic elements. They go away, or they just stay exactly where they are when the world moves on to the next phase. And there's a lot of historical evidence where this happened in previous cases. So when we talk about what is going to happen in the consumer world, the only thing I would not look at is makers for that matter. And also the idea of like, let's make these consumers makers may also not, in my personal book, may not be the best approach to doing this. And I know, as much as I would personally want that to be. This is, as a maker, that's a great object, right? But it serves no practical purpose, obviously. So if makers are not a good way of predicting the future, what might be? So in this journal paper, Stefanie and I discussed this topic, and we feel like maybe a better approach to this is if we think about what fields have similar structure, and let's see where they went. Maybe we can find analogies there. And take this with a grain of salt, obviously. Predicting the future, 50% accuracy at guessing here. So what does similar mean is an interesting question. So, and when it comes to similarity, we feel like the structure may actually be relevant here. So let me show you, this is a traditional analog workflow. You have an object, for example, a cup, and you want a second cup, so you stick it into a copy machine. And let me see if I have sound here. Let me show you a machine that you may be familiar with. This is a key. I don't know if you ever lost a key. I have certainly a lot. And so you go to like someone like Mr. Miller or something, and they have a second key. It's a blank, looks the same. And this is actually like a mechanical scanner and a mechanical milling machine. They're mechanically coupled. So I hope you remember the sound. All right, I'll mute the sound here. So the right side traces the key and mechanically coupled, shifts and turns and engraves that into the right side. So this is an old traditional analog workflow. You have a mechanical problem, you solve it mechanically using a highly specialized machine. But you can have a different workflow, which is you actually scan the object first, you create a solution in computer science space because now you're dealing with data, then you print it and you have your mechanical solution. And at first glance that seems very wasteful because instead of having one machine, you have two machines now. A scanner and a printer. But the kicker is that in the middle now you have an interesting object, which is a digital object, and that thing actually has an interesting set of capabilities. And me being a computer scientist, this means we're in computer science land, right? So if you have any training in this area, independent of everything with the physical world, now, this is where we come, into the action here. So it enables a couple of new workflows. Let me just show a traditional one. This is a super traditional problem from industry. Car industry needs to maintain replacement parts for all old models. And so if you're like a proud owner of a '74 Volkswagen Golf, If you kind of, get a ding onto the bumper, then Golf has, like VW has to have a bumper cap for you. They're going to sell it to you at like a tremendous price because it's very expensive for them to maintain that. And when they run out of the 500 they have in store, they have to run a new production round. So that's really something no one wants. So they, at this point, they start producing this on demand using additive manufacturing. But you can also think of a slightly more advanced future where this is sent to a fab lab in your street, and maybe some even better future where this has been worked out with lawyers and IP issues, where this is actually mailed like to your living room, and while you're still fixing the car, the part shows up. So at this point, essentially, when you look at this workflow I just described, that's not a typical physical workflow. That's a SAP workflow. That's like database and logistics and things like that. So, but the real kicker of this whole thing is once you have set up a pipeline like this, you can give it new functionality by doing a software update, and that's huge. So the key copy machine I just showed you will not do anything but copying keys, and if you need anything else, you have to buy a new machine. But for example, here at this point, in the Kai community and the SIGCHI community are really good at this, you can actually put some clever software in here. So maybe you're scanning an object, you put an object into a copy machine, and it's broken, and the result that comes out has been repaired, right? Because the object has been identified, the data has been looked up, and so all these things are software things. And that's actually very powerful because you have to ship only a small number of these machines, and transferring the hardware problem to software problem is one of the key elements that really empower community. If you think about like the Apple App Store and like 1 million applications in the iPhone App Store and the same in like Google Play, this is certainly a tremendous amplifier for like a community. So if you believe me for a second that this, I sometimes call this ADDA for analog digital analog converter, that's the underlying pattern. Well, how have all these other systems that are built on that pattern performed in the past? And the answer is tremendously. So here's, a pattern from the 80s, depending on which time you want to use for that, desktop publishing. So when you guys all get your Kai papers accepted and you get this email that says like, please submit the camera ready copy. I don't know, did you check where the camera is? That camera hasn't, this used to be like, put under glass and the camera from above, and that camera hasn't been there in a long time. Because once, scanners reached 600 DPIs, and then, Gary Starkweather's invention of the laser printer became 600 DPI, this became the only game in town somehow, right? No one has done manual layout ever since. Tremendously disruptive. Same for music production. I can't sing, I can barely play an instrument, but I can certainly produce a record today. This is one of my favorites, 1970s, Dick Schaub at Park. He brought in artist friends at night. They used the Alto computer and sucked down individual frames from tape into Alto computers, painted around in it, and put it back on tape in the morning. And this guy was threatened to be fired from Park because he was obviously wasting company resources by doing meaningless stuff with computers, except that he invented this digital video editing, which is also $1 billion or $1 trillion business, if you will. So, and if you really want to go back, even like the entry and output of text is kind of fulfills the same pattern of these things. So every time I personally have seen this pattern, it's been tremendously impactful. Some analog field became a digital field. You could argue it's become part of computer science. You can also argue the opposite if you want. A lot of new jobs were created. A lot of people lost their jobs. So tremendously disruptive any time it happened. And I think that's exactly what we're about to witness, at least in my vision of the future. We're going to see that with physical things. With 3D printers. And the difference is this time it's going to be a large number of fields affected, from industrial design to structural engineering, mechanical engineering, everything that deals with physical matter, because traditionally computer science was really limited to data in, data out, and now that limitation has been removed. So the key question is, if we think that's actually an interesting thing to go into, so what did these other fields do in order to achieve that transition, from tech enthusiasts to consumers? And the answer is, for this transition to take place, first software had to be made that allowed consumers, like inexperienced users, to perform the expert task. And that's something that the Kai community has been tremendously good at over the past decades. Taking something that traditionally has only been performed by expert users and embodying all the necessary smarts and engineering into the software so that novice users could perform it. So typically, as I was saying, for desktop publishing, first you need some hardware. Right, and for Fab, we're still at the point where we kind of like it, but we would really like a 3D printer that's 100 times faster than a Carbon. So there's still a tremendous amount of change about to happen. You need good scanners and you need good printers. But then it's kind of, and that's, you know, sometimes the Chi community contributes to things. Scott Hudson made a wonderful, you know, 3D printer for soft materials, and, you know, many of you have made things in that space. But then the space, actually, the next layer is the one where Chi really, truly comes in, which is the software and user layer. One of them is domain knowledge, right? So if you make a system that helps, you know, amateur users perform an expert task, all the smarts have to be in the software. I think Takeo Igarashi is one of the people who have done tremendously well in that space in his lab, where they, you know, produced software that allows people to design planes that actually fly, which is very cool. On the same note, the structure you saw upstairs, the pavilion, is a software package that actually, you know, knows a lot about structural engineering and allows people to create these, like, you know, 6-meter tall structures. The next thing is, and this was called WYSIWYG in the 80s, what you see is what you get. This was the idea of desktop publishing, that as you're doing things, you kind of see where that's going. So having visual control is tremendously useful. If you're an expert, you don't need to, you just, like, you know, measure twice, cut once, and then everything will be fine. But if you're like a novice user, you probably need more feedback in the process. And so, you know, we see a lot of fabrication. All right. We see a lot of systems that actually, you know, add interactivity, and Stefanie is one of the people tremendously contribute to that, and Carl and so on. Machine knowledge, a lot of things actually came out of Bjoern's lab and among many others. If you throw new machinery at people, you also need software that helps them overcome the hurdles built into those issues. So what would it take for personal fabrication to transition to consumers? So this is exactly the same thing. It's exactly the same pattern, we think. We need hardware materials. You know, we need essentially the right, you know, interactivity. We need systems that incorporate domain knowledge. And I think domain knowledge is one of the things where the Chi community could do a bit more, because a lot of this stuff happens in SIGGRAPH actually right now. So I think that's, you know, obviously it's great to work together, but it would be great to see more in the Chi community as well. And machine-specific knowledge. And let me just, in the journal paper, this is what makes up the bulk, essentially. We took the really work that we could find and partitioned it into those different things. And so, for example, if you just look at materials and hardware, we break this down to like 10 subcategories that explain all the different elements of that. And on top of that, in the journal paper, we're adding another layer on top, which is the societal layer, which is traditionally kind of discussed, I think, after the... I'm not sure why I'm losing connection here. Sustainability, just the materials that we use, but also the machines themselves. We're going to be running into something of a Moore's Law situation, where a lot of new machines will be bought and disposed of, and dealing with that issue today would be great before we actually run into this. It would be great to you know, deal with these things before they become issues. Intellectual property, all the things I showed you earlier, you know, music, film, and so on, all of those end up with tremendous amounts of money going to lawyers. Which I guess is fine, but may not be the best way for a field to move forward. So if for once people could, like, pick this up as a topic, and, you know, we could do better than these previous fields, that would certainly be welcome. So in the paper, we're trying to make this a little bit actionable for researchers, and the way we do this is we kind of go back to this timeline I showed you earlier, and the key question we all want to know is, like, what's going to be there, like, what's the future of fabrication? Well, we say, like, well, we don't know this, but if we kind of all agree on, just for the purpose of this analogy, that this could be similar to what we saw in personal computing there at the bottom, then, you know, we could just say, like, well, let's pick some random events that happened after 1975 in computing, for example, the Park Tap, Apple Newton, Palm Pilot, and today's mobile devices, and say, like, well, what happened if we got the same thing in fabrication? So this is actually a paper that Thijs is the first author on, that we published at WIST last time, where we're wondering what happens if people carry a 3D printer with them at all times. And as funny, as ridiculous as it sounds, it's pretty much as funny, as ridiculous as it sounded in 1975 if you had said, like, well, what happens if you carry your VEX in your pocket? You know, because that thing actually weighed like 200 pounds at the time. But it turns out, I actually think that's going to happen, because for the same reason that mobile is going to happen, because it allows you to solve problems on the spot when you need them. So in the journal paper, we give some sort of an overview for different fields. We're trying to map where we think fab stands with respect to today, and depending on what aspect you're looking at, we're somewhere between the 60s and the 80s. And I think that's kind of a cool perspective somehow, if you think about it. So depending on what aspect we're working on, we're kind of pioneers in a way, and kind of working away on the space. So, and what else is here? Well, if you think of all the things that happened in Chi after that, CCW, Ubicom, computational geometry, crowd computing, and so on, all these things can be applied to fabrication. And again, we try to speculate a little bit on this. So, so hopefully this analogy will not just be for illustrative purpose, but actually help, people generate interesting research questions. So the last point I want to make is when is it going to happen? And I think that's always something we underestimate. Somehow we feel like, when we're judging the quality of fabrication, we're asking like, how good is it today? And like, they're at Walmart, like, are we there yet? Is it ready? We're impatient and we're kind of expecting it to deliver very soon. And so in the lab, we had a lot of discussion about, well, when did the transition to consumers happen for computing? And I think that's a really interesting question. And you can think about this in your own head for a second. Like since when has computing been a consumer accessible business? So think about when was the first time you could buy a computing device that you could give to any member of your family? And so just for me personally, I chose 2011, which was the point at which you could get an iPad that ran without a laptop computer. Right? This was the first time, so there was an app store, but this was the first time you could actually have that device without having it connected to a personal computer. Because the personal computer, at least in my family, could not be maintained, but the iPad kind of could. So just for me, I picked that number. You can pick any other number you want, but for me, that number was actually 36 years after the 8800 processor that kind of started the hacker kind of revolution with people like Steve Wozniak. So when we're judging the potential of personal fabrication, maybe we should not be that impatient. We should just understand that we still have a long road ahead of us and give ourselves some time, and don't try to, let's not make the mistake of judging the quality of personal fabrication by what we see necessarily happening in the maker movement today. All right, that's all I want to talk about, and let's start the panel. You have the URL there. So. I think the first question you would like to throw into the round is where does everyone feel this we are going with personal fabrication? Where do you see major roadblocks? And anyone feel invited to answer that question or ask another question as well. And the issues that we talked this morning at breakfast, so everyone feels like, oh, I've already said that.
So one thing I've been mulling over, I'm not sure I have an answer for, is the question, who are the people in personal fabrication? Is it really something that will go into every home, or should we look at other people who were not users of digital fabrication in that first industrial period, but who might have a business interest in bringing digital fabrication into their process? So I think you've already seen this in jewelry, that you walk into any jewelry shop in San Francisco and there's the rack of laser cut, bracelets and earrings, and there are the 3D printed pendants, etc. You've seen this in dentistry, right? Invisalign braces and general dental implants, everything gets 3D scanned and 3D printed in higher end places. And to me, one of the really interesting next places to look at is contractors. So you're remodeling your home, you're calling in the plumber to fix something. What's going to be the domain specific digital fab that is going to come in their van or on the back of their pickup truck? Because if you find that it's actually worth their while to invest in that equipment, then I think that'll take off as a whole industry in itself.
Patrick gave me a task to maybe challenge some of the notions here. Unfortunately, I think in the physical world you have something called gravity, right? So that's not there during all the stuff we heard when Schneiderman spoke and so on. They had to deal with widgets and they could write code and get away with it. So I'm not sure how much a lot of the analogies carry over, and I don't know if people really want to make things, you know. If I go to the Maker Faire and so on, I see a lot of people out there, and they're all curious people walking around, but I'm not sure they want to make stuff. So I think this whole industry may just become a service industry. You know, perhaps I think that maybe we are seeing some trends there. UPS, next day delivery from Louisville, and they want to use drones to give stuff. I don't know. So I'm sort of projecting the service side, maybe the big winner here.
So some audience participation. How many of you cook? How many of you cook from a recipe book from scratch versus, and how many, well, yeah, so how many of you consider yourselves to be sort of expert cooks? Okay. How many buy things in a store that help you cook? Yeah. Like, I'm thinking about prepackaged foods that you can heat up or things like that. How many do that? Anyone willing to admit it? Okay. Yep. And then there's all those machines we use for cooking, right? From my mom just tried to convince me that I really want the pot that is both a slow cooker and a pressure cooker that she and my dad now use for all their meals. So when I mean, just since we're throwing analogies out, I think cooking is a really interesting analogy because it's something that more so than, say, knitting or other crafts transitions all the way from going to a restaurant to get food to somebody who is learning how to make their own croissants at home, right? And everything in between. And so, and it leverages tools to do that, right? And the tools vary quite a lot in how much they do for you. So maybe that's a way to think about, at least on the consumer end, where we might end up one day with fabrication, in analogy. I'll just throw that out there.
So I cook. I cook for the taste, and I cook for the pleasure, and I cook for the feeling of being an expert or acquiring expertise. If I really wanted an excellent meal, I could go buy one at a restaurant, as Jen just said. So the reason we make things, the reason we cook, the reason we write is largely, from the personal perspective, to feel like an expert, to feel like I did something I'm proud of. And it's not easy, so I've made many bad recipes and then improved them. And so there's that. Patrick mentioned I objected to the word consumer, and I meant citizen in the broad sense of human member of society. Consumer seems a really weird word to use when we're talking about personal fabrication, which is about producer. So I'd like to, consumer turns us into people whose job it is to buy things from, right, to consume things to. So I found that a really strange dichotomy.
So now that you say that, now I start liking the word consumer. Because I think so if you remember when the iPad came out, I think Apple was visibly taken by the criticism that the iPad was something that allowed people to consume stuff but not to produce, right? And they really threw everything in to make sure that, productivity apps would come to the iPad and so on. But the truth is that that these devices are pretty good at sitting back and playing Angry Birds and browsing Facebook and YouTube or whatever, and actually engaging in reasonably passive things. And I think that's actually in my book, that's actually one of the challenges that I think. I think the issue is everyone in this room probably, I assume, how many of you are makers? All right, so the difficulty is if we want to design for a post-maker world, it's very difficult somehow, right? I mean, if you look at people, if you ride the bus in the morning, you just look at random people around you, what exactly, many of them have a mobile phone. They're playing they're aligning jewels somehow in some way, because, jewels need to be lined. And so it's very difficult for us, I think, to kind of identify with these people and think about what would it take for them actually to find use in that. And but that's a critical question at some point, right? This determines at the end of the day the size of the market, just in the absence of a better word. So I would be kind of curious to hear what people think. What does it take, or what is holding, why is the technology today only limited to the people people like us? What would it take, for technology to go out and have more, appeal? How many of you have a 3D print at home, actually? I'm kind of curious. Okay. Wow, that's okay. That's so okay, Scott Hudson. I knew that. Well, sure. So I'll be kind of curious also from the audience. What do you think is holding us back right now? If you could have one wish, what would it be? What feature? A faster printer, or like more materials, or what would it be? And you just yell out, and we'll repeat.
Cheap MJM.
Oh, actually, doesn't matter.
Cheap MJM, multi-jet modeling. Cheap MJM, where the
Cheap multi-material or multicolor or?
no, multi-jet, like the jet printing and UV curing process, which is like, as far as I can see, an order of magnitude more expensive than FDM right now. If that gets cheaper, it's going to be like this machine that you buy that malfunctions rarely as your car. I mean, if it malfunctions, you go bring it to the shop, get it fixed, get it back. FDM is not like that. It's super problematic, but if it was cheap enough, you get it, you press a button, and this is probably the more boring part. Like the CS part, I'm skipping ahead. That's really the interesting part, but that part, if you could get it for free and press the button and the input comes and out comes the object, and you don't think about what's happening in between, that's what I think consumers are in need of from the actual physical.
I was going to say that for the most part, I don't think materials have kept up with the development that's been done in the fabrication work that's within HCI, SIGCHI. If we look, say, take wire print as an example, I think in the last 3 years there's been 3 iterations on that printer, make prints faster, use different materials and whatnot. But if we take food as an example, when we cook, some of our ingredients are solid, some are more liquid, more viscous and whatnot. But fused deposition modeling, fluid deposition modeling, they still tend to be very separate models, and it's not how the real world works for people. So if you want to create a connection between the way the world works for non-makers versus how we can see it go towards the future, I think there has to be a larger effort towards creating new materials and methods for introducing those materials to the fabrication world.
I think my favorite tools in making are those that directly manipulate the thing that I'm trying to shape. So the biggest frustration in, let's say, 3D printing is this thing that I have to go to the desktop computer, and then when something comes out, and is it the right shape, I got to modify, and then this whole process of disconnected with direct manipulation. If I'm welding something and I'm just attaching things together, it feels really good because the result is right there. So I think that's the toughest part right now, of at least this portion, or this part of the tool that we're using for making.
I think it's always interesting in my lab when a 3D print breaks, everyone reprints. Sometimes all you need is a hot needle, right? But it's just the moment we're using digital tools, we just forget that the materials, they can be fixed and glued and all these things, right? It's kind of weird.
Francis Quack, Texas A&M. I'd like to reverse the question. You asked what kind of features you will need before you think the fabrication will take off. I'm old enough to remember 1984, right? When Steve Jobs married up, raster screen with PostScript and gave birth to desktop publication, right? The image writer at first and then laser writer. If I were to ask you back then, if I were to have a panel like this and ask you, what will it take for us to get these printers into every home, right? We could come up with a set of features. But I do not know many people today who own laser printers at home. I mean, I have a color printer and a laser printer, but I'm not the average bear, right? I work in the information world. Right? So, we saw, if you think back in 1984, to be able to produce something equivalent to $300 an inch was an industrial process. You had to make a plate. It was called offset printing. There was a minimum run of 1,000 copies before this thing will come down to $10 a sheet or $100 a sheet. I can't remember what it was. It was something exorbitant. We used mimeographs and we used ditto machines to turn out cruddy stuff, right? And if back then, the imagination, we all took off with this imagination that personal printers and personal publication will turn us all into plumber poets, right? But our world did not end up that way. Very few, we don't even talk about desktop publication anymore. Some people own a laptop and maybe one 3D printer at home. But so how would that parallel our vision today of personal production?
Yeah, so we also had this discussion, right? So maybe do we end up with something where people will have it at home and then they will not have it at home anymore? So, right? I think the difference, or what we discussed or came to the conclusion is, if you just print out a photo, so there's no difference from viewing it on an iPad versus having it printed out. It's just 2D information, right? Versus if you have physical objects, you really use them in your environment, right? So there's a big difference between let's say a virtual bike versus a physical bike that you can actually use to drive around, or a virtual pen versus a physical pen or physical knife handle, right? So there's a big difference between information only, which is basically photo, music, and all of these other types of media we have seen, versus physical products that you use in a physical environment.
Just a comment to follow up on Francis and Stephanie. In the physical world, once let's say you're able to make a bike or something like that, there's too many things that can go wrong. And there's dynamics, physics, friction, tolerances, strength, durability, et cetera, et cetera. So unless we as a community start making utility applications that get traction in the real world, like businesses start developing, and the analogy they use, the community developed respect because it was helping society. We are still far away from going beyond simple things in the real world, and much of all the work that I'm seeing in the electronics and everything, some of these have to catch on in real applications that people will buy and use, and it satisfies them and they're reliable.
I guess you asked about what we want in the future in a way, and I think for me there are three things within 3D printing specifically that I'm kind of hoping are developed better in the future. I mean, one of them you've already touched on is multi-material printing and finding materials that are kind of more compatible with this process, specifically with FDM, because I guess that's the most accessible technology for home users. And then the second is developing materials that are kind of, so my background was previously in aerospace engineering, and I worked as a material scientist trying to take inspiration from nature, 3D printing it, and then trying to make it, trying to kind of put it into more, I guess, engineering-based structural applications, and that was often challenging because the materials are made for prototyping rather than for engineering purposes. The other thing is a design from additive manufacturing approach, because a lot of times, you create a design using subtractive software, you put it into a 3D printer, and it's never really what you get out. So there's that iterative process that still kind of needs to be refined a lot more.
So keep contributing these things, but let me just throw in one more question, which is not about you, because we all agree, most of them in this room are makers, but what would it take for your mom or your dad for them to actually buy a 3D printer? So I think what makes the hurdle for you may be quite different than for them, right? And I'm kind of just speculation. Maybe for us it's the hardware because we have the software down. We're experts, right? We know how to, work the tolerances and how to do this. I'm kind of speculating that maybe for them it's more the software than the hardware, but I don't know. I'm curious to hear your thoughts on that, and everyone on the panel for that matter.
Let me just make one other analogy to programming in general. And there's a nice distinction between incidental complexity and core complexity. So incidental complexity, I like Philip Guo's phrase of command line bullshittery. Like all of the magic incantations that some people really get into, but for other people just get in the way of moving towards their goal. So that with good design, right, you can make that problem go away. But there is that the core complexity, which I very much agree with Karthik. There are all these other considerations if you want an object that's not just, it exists as a shape in the world, but it fulfills a function and does so robustly and safely. And that, getting that right, in the general case seems very complicated, but I think you brought up the approach of embodying domain knowledge, in particular verticals, into the software, and that's maybe where one application at a time we can make inroads.
So I'm going to take issue with the issue of complexity just a little bit. my parents are very handy people, but very little of what they make is mechanically complex. And if they were to have something in the home, I think what they would want would be something that involved clay and wood and cloth and could print at a scale that we don't think about as normally part of printers. And if those things were satisfied, I bet they would happily do many interesting things with it.
Yeah, sorry, now you crashed my question, but Carsten, FabLab Camp Linford in Germany. I don't know the future of personal fabrication. I also don't know the future of, or the need, the core need that we can address here. But I see a kind of development that is going on already. So I'm running a Fab Lab. I see a lot of people doing things. And what I really like on that is we enable people to do things on their own, again, which we have lost in the past. Because the education system, most of us are well educated, and all of us, and okay, all of us, but we are specialized in a certain way because our educational system made us specialists in something, and the Fab Lab or any makerspace or whatever gets us back to something to be more generic, to be more handcrafted, you can say, even when we use tools. And the new tools that we have, as a printer or a laser cutter or whatever, just enable us to make something different, maybe something more complex than we were not even able to think about. The new tools enable us to do things we were not considering before. And this is more like kind of a statement. So it could, to me, the future of personal fabrication is being able to do as many things as possible.
All right, yeah, I already got the word of the day out of this command line bullshittery is great, so thank you for bringing that up. Jan Borges from RWH Aachen University. I have two questions. David Little, the guy who sort of helped build the STAR computer, had this wonderful model that he published years ago of 3 phases of technology adoption. And it had a phase in between that I didn't see in your projection, which went directly from makers to, or technology enthusiasts, as you call them, to consumers. He actually had business users in there as an intermediary phase, going back to what you said, Bjoern. And I'm wondering about 2 things. Well, first of all, his model applied really well to a bunch of things. You take smartphones or cell phones in general. First, it was for geeks only. You got a package from, your electronics supplier, and you built your own phone. Then business users found an actual need because it, paid their bills or made it cheaper to ship stuff around. And then, consumers got into it. And yeah, the word consumer is a little sort of derogative, maybe even, but it points to, I think, personal use is actually probably better, where the delight in the system and the ease of use and the enjoyment of making this part of your everyday life becomes really important. So does that model still apply? That's my first question. Would that actually still apply? Are we going to see a similar transition where actually before everybody's doing personal consumer things in their homes with 3D printing, there's going to be this phase or emphasis on just people making money with it? And you mentioned the jewelry stores that are selling these 3D printed goods. It seems to be going that way. So maybe not think about, technology enthusiast to consumer. I think there's something in between. And again, I totally agree with Pat. We may just have to leave it some time to happen. Now the other thing is, I know this article from David Little so well because I sort of wrote an extension of his model and added a 4th phase to it in an interactions article, and that phase was the Baroque phase, which is the phase once the technology has reached that point, that sweet spot of, it's really useful for even, consumers for personal use, then, industry's struggling, okay, what else are we going to add to it to keep selling stuff? And then you get, the Baroque embellishments of stuff that make things, useless. I remember, NavSat systems that started having slideshow functions on there for like a GPS in your car, right? So the second question that I'm mulling over, and maybe you've got ideas, is there going to be a Baroque phase of, personal fabrication technologies? And if so, should we maybe do speculative design and imagine the most, terrible Baroque embellishments that people could add to 3D printers or 3D printing technology once it's already in everybody's home, and we are wondering how to sell version 2?
question.
Thanks. This is a great. I'm just dumbfounded. This is a great comment because that means you actually think another 20 years past, right? Maybe that's a good way of thinking about the consumer phase by pushing ourselves even 20 years further. I think that's a really good approach.
Thanks. I'm Bjoern from Purdue University. So I have two questions. One is because I think the personal fabrication is relying on the development of material and manufacturing process. So as a researcher in a personal fabrication area, what do you look at this issue? I mean, do we need to participate in the development of the process, or we just sit and wait for others to solve the problem?
Yeah, so we hear a lot of material questions here. I wouldn't actually not be too worried about that. So if I read Advanced Materials, it's a journal, and if you look there, there's a ton of new innovation in 3D printing materials every single day, and it just will take a little bit, or if you're at a large university, you just go over, you talk to them, and you ask them if you can use their material for other purposes in terms of HCI and user interface design and new design tools. But there's a ton of development going on, and just this plastic 3D printing that we see right now, that's only the first thing that hit the consumer market, so I wouldn't be worried about that at all.
So it's true that, so comparatively, I think there's much more action right now in the materials space than in the underlying mechanisms of 3D printers. Those have pretty much stayed the same, right? You have nozzle, you have multi-jetting, you have sintering, UV curing, and so the actions in the materials. But even there, so let me channel someone else with. So I think I believe it was Saul Griffiths who said 3D printing is like the gateway drug for computer scientists because it's so immediately accessible. The delta from my existing skill set in software to hitting a button and out pops this object. But actually, there's vast untapped potential in understanding all of the other fabrication processes we have. So CNC, anything, right? So for example, in our makerspace at Berkeley, the CNC router is now getting a ton of use, and as well as doing circuit board milling, so subtractive process just at smaller scale. And so all of these processes are there. We don't have to wait for a big material innovation to come along, but yet still they're mostly used in this industrial mode that Patrick mentioned, and just thinking about all of the business enthusiast amateur to consumer/citizen applications for those, whether those machines are in your home or they're at Home Depot or they're at your local tech shop. I think there's just vast amounts of opportunity.
Okay, so my second question is more practical. So I'm wondering for the students who are working in the personal fabrication area, where do you think they can find a job in the market? Because myself have some problems when looking for jobs.
We're hiring. I've got to start up. We're hiring.
Thanks.
Yeah, I mean, depends on if you want to find a job right now or if you're asking the question in 2050, where will you find a job then? I think then, it's a more future-oriented question. I think right now there are a ton of companies, and depends on if you want to go to industry research, right? I don't want to make advertisement, but I know Adobe is searching, Autodesk is doing a lot of stuff, tons of other research labs going in this field, so,
Yeah, actually I got a job as a faculty member, but the thing is I got a job not because I'm working in personal fabrication, because my ME background. Yeah.
No, I just have a comment on Patrick's idea of analogies, right? So I think personal fab is raising the barrier of what you can do, but still you need a lot of knowledge on making things and everything else. So as long as students can take that knowledge in fab and translate it to other kinds of manufacturing and materials and processes, they just become good at the physical part of building things.
So I guess I can try to answer the question of where the jobs could be, because I've been spending a little bit of time in the industry by now. But to start, I'm going to tell a little story. I was in the research in the same time as Carl Willis and my co-Boulder, looking at personal fabrication, get people engaged in these systems, and we witnessed all the difficulties in the measurement, in the tolerance, and all the things, and I was really happy to see all the solution coming along. But then I ran into some stuff that almost destroyed my faith in this. Last year I got into this gig that I was doing a personally designed system. So people come into the bank and they design the pattern on their credit card, a very personalized thing. There's nothing 3D or bending fixed or anything. And we spent the summer designing it. When we finally ran the user study on this, where people come in and start designing things, it wasn't, the feedback we got wasn't like, is the graphics smooth, is it beautiful, is it anything, but rather, can you please just give me the system default, because I don't think I'm a good designer, and my thing is definitely worse than what I was given, which, because I designed it, I know it's just a random generator from it within the system. So I think with all the technical advancement, people are not ready to do this thing, and they have another ones with us. So I think there's some question to be answered there. And on the other hand, to answer the question on where the job is, I think the industry has witnessed this trend of instead of giving you unique, luxurious goods that you can buy, they're trying to sell you experiences. That look at this thing, like I made it with my kid and her name is embedded in it or something like that, and they can go off and try to boast out them. And there's a tremendous demand in conferences where people want to come in, they want something new to go away with and like go to their team and boast about it. And I would suggest that if you're into personalized fabrication, you can start doing those and sell them as experiences.
Thank you. So just real quick, here's what we're going to do. We're out of time officially, but I think these two people have been studying light for quite a while, so that's okay. Stick around. We should just hear these two people real quick. Maybe you can make it short. Then we should officially, say words of thanks, and then we should all huddle and just keep doing this. All right.
Make mine short. I was just thinking of something in response to what you had asked, which is your parents or whatnot. So my sister bought one, a 3D printer, and she's not really into technology on that level. So when I went to her place, she had it for 2 years, and her husband had bought it for her. It was like $3,000 maker bot, and she didn't even touch it, even though she had wanted to make something. And so he was telling me to kind of show her how to use it, and I kind of like fiddling with that stuff, so I'm playing around with it. And I printed out this, she was just making a very easy thing, and I showed her the steps, which I thought was pretty straightforward, and she just lost attention when I started, just showing how to place a thing on the platform in the software, and she's just like, why? And I'm like, well, that's a good question. I guess it didn't default to that. And so I said, well, just do that, and if that happens, just do that. And then we go to the printer, and the nozzle got clogged, and so I started fixing that, and it turned out that was just a level of things she didn't want to deal with. Because I had to take out the wrench, and so after I left, and this is like months ago, she still hasn't used it, and so I think it's usability, and I'm thinking that there's little hello world things for software, but in hardware for a 3D printer, maybe have like a little test printout, which that one had, but there's no way for her to ramp up from there, so the usability I think is a factor for things like that.
So my question is about the ADDA process, actually, so the software part. So we have seen this year very happily growing the community of digital fabrication, but we also have seen virtual reality growing. So my question comes to, why do we actually bring back from digital to analog? Because let's say, I'm trying to think not like a maker. Let's say you live in a digital world. Let's say I'm going around with totally something that covers my view. Now, most of the things I have around could actually be just digital. I don't have to print them back. So why do I need that physical item? Why would you say it's important? Thank you.
So I mean, it's a little bit what Stefanie was alluding to is that you know, if you can make a physical bike or so, these are factors of an actual drone or so. But I think this is an interesting debate we had. There was a closing keynote at WIST a year ago or so, and the speaker debated all the things, how long it would take if you were trapped in a, I don't know, some sort of a booth and you didn't have anything. Were you naked? I don't recall. And but all you had was your mobile phone. It would take the rest of the world quite a while to find out that this happened to you, because you can essentially perform most of your social functions with your mobile phone trapped somewhere. And so after this thing, we started debating. And I think it's an interesting question. So when we talk about the long-term future of fabrication, an interesting question is, you know, there could be a trend to more stuff and a trend to less stuff. It could become a fashion thing where, like, 5 years we all agree we need a lot of stuff at home, and then for 5 years, you know, we have, you know, spatial augmented reality where we just have white everything and we just project stuff on it. And I think these are all viable possible futures in that space. All right, I think we all would love to discuss more with you. We just want to give everyone who feels like they need to catch a bus right now a chance to leave this room politely. So let me point you one more. This is the chance to get the paper for free, shoutkey.com/pair. Also feel free to email us if you disagree or agree or have any other opinions, or, you know, the paper that we forgot to mention. And then with that, I would like to thank most of all the audience, like all of you, and then everyone on this panel. Thank you so much.